We're delighted to invite, first of all, Keith to speak to us, and then Doug will speak to us, and then we'll have a bit of a discussion, and I really hope you'll join that discussion, because this is meant to be an exhibition about dialogue and not monologue, so I hope you'll save your questions, and we'll have a conversation at the end. So, Keith, can I invite you to the stage?
Okay. Thanks very much. Okay, thank you very much. So the microphone's on, right, good. Let's go the other way. That's right. So, 3 women. David said we don't have many women here, so I was starting off with 3 women. So in the beginning, how did it all start? Well, when I was little, I loved trampolines. They came along, and I thought, I really want one of those. But in those days, you couldn't buy them unless you bought a gymnastic trampoline. And the school that I was at, Auckland Grammar, had a gymnastic trampoline. And we were allowed to go to the gym and we'd line up with the rest of the class, and you were allowed to get on, have 3 bounces and a seat drop and get off. And there was 30 kids that have to go through. And so that was it. That's all you could get. I really wanted a trampoline. I started to make one myself when I was 16, never finished it. So when I grew up, took a long time, got married, and then had a daughter of my own, I thought, now we've got to get a trampoline. She's far too young for it, but we've got to get a trampoline. So here it is. We should get a trampoline for Katie, I'm saying to my wife. And she says, no, dear, they're too dangerous. And I think, what do you know about trampolines? I love trampolines. They're really cool. And what do you mean they're too dangerous? So there's a bit of tension there. And that tension, drives you to do stuff. I didn't want to argue with her, but I thought, I know better than this. So I started doing the research. I looked around and to see what evidence there was that trampolines were dangerous. She was going to Play Centre and they all said trampolines are dangerous. I thought, well, Play Centre might think that, but I don't believe they are. But I found this paper. Dr. David Charms, University of Otago, had written a paper called A Decade of Injuries. And he actually showed that, yes, indeed, trampolines were increasingly dangerous. Well, he didn't really show that. He just showed that there were more and more injuries from trampolines. And realistically, that wasn't because they were dangerous. It was, I'm making excuses here. It's because the market was increasing and more of them were selling. So, well, when you look around, and I started looking around, of course, I found plenty of reasons why they were dangerous. They didn't have padding on them. Most of them didn't have padding on them. We've got this photo here. That guy didn't really get caught in the act of doing some terrible damage to himself, but that's the idea, and there's plenty of stories. I have to say, whenever I talk about the trampoline, there's always people who come up and want to tell me their terrible story about trampolines. Later on, people put nets on to stop you falling off, but the nets tend to fall apart, and that little kid really did go through that hole in the net and land on his arm and break his arm. But seeing that there were injuries and seeing that they were dangerous really got me thinking. I thought, I'm an engineer, maybe I can do something about this, and maybe I'll be able to get trampolines in my backyard somehow. So that was my personal goal, to make trampolines safer, and I thought that the main thing was those steel edges. That was the biggest problem. So I wanted to get rid of that steel edge and make it with a soft edge. So then I started thinking about it. The first one that I tried was an inflatable sea biscuit that I borrowed from somebody, and I got a bit of trampoline mat sewn up, and I tied springs on there, and well, the time came for testing it, and it was just when William should have been in bed, but I could grab him and haul him out there, and he bounced on it, and there he is actually jumping. I got a photo of him. And my wife's in the background saying that he should be in bed. She didn't really, I just made that up. But anyway, it was good. So there's my first idea, and it seemed to be successful. So I did what engineers do, and then I designed one up, and I got a canvas company to actually make it into this octagonal trampoline. And it was, in many ways, really successful. That curved edge, you couldn't hurt yourself on. The little kids would slide off. No parent was worried about the kid sliding off it. But it ended up that the material cost was about $800–900, and that's really expensive for a trampoline. That's just the material cost. That's without sewing it, and without gluing it together, and there's no profit in that. So it was just very unrealistic. So way too expensive. It always leaked. whenever the kids wanted to use it, you have to get out the vacuum cleaner, put it on blow, pump it up, and it'd be okay for 3 or 4 hours, and then it'd start to go flat again, and no one would be interested in it for a week, and you have to pump it up again. And the worst thing about it wasn't very bouncy. So from my point of view as a person who wanted a trampoline, that wasn't very good. Okay, you see some little kids there. The one on the left is my son, who you saw in the last picture. So he's grown up a little bit here. And the one in the middle is my daughter, who happens to be sitting down here. Okay, so from there, I went on to thinking about more ideas. So here's idea number 2. I'm trying to think of other ways of making a trampoline that's got soft edges and is going to be more bouncy. And you can see some alkathene pipe there cut into a shape to hold a rod that's pushing up from inside it, which you can see down on the bottom left-hand side. There's a rod there and something that looks like a drum. And that was the kind of idea, one of the ideas I had. About that time, I moved to University of Canterbury, got a job there, and then I had this as a student project. So here is what resulted from the student project. So we've got a little model there that represents a trampoline. The string across the top represents the mat. And you can see that if you push in the middle, it's going to deflect downwards, but you could also push those rods on the edge and they would deflect, so it had a soft edge. Using that idea, I decided I'd try and get some funding, and I applied for 2 places, and I got funding from both of them, which was wonderful. So what do? Do I give some of it back? Or I didn't know, but anyway, the first thing I was going to do was make this into a full-size one. So, sorry, go back again here. So there, after the summer was over and I'd had a student scholarship for it, we had a trampoline idea number 2 actually made. And that little girl in the yellow dress is jumping on it there. It looks as if she's enjoying herself. She's actually working really hard. This was about the worst bounce on a trampoline that I ever had. It was very, very soggy. And if you looked underneath it, it had twice as many springs as any other trampoline for the same size. So it was very complicated and very expensive, and I wasn't going to go there. We only ever made one of those. So then I started thinking of other ways of making the springs, and this here is a little sketch of the steel springs that I thought that I needed. They were about 10 millimeters diameter and multiple coils, and I very soon found that when I took it to a spring manufacturer, and he said, well, every time you bend it around, it costs you another $1. So these springs with multiple coils cost something like $7 each, and if you had 90 of them or 100 of them in a trampoline, well, that's a lot of money. So it was going to suck up all the money just in the springs. So then I started thinking of idea number 4. Let's have a spring, if you can, without any coils in it at all. Maybe it's just curved, and you can see that one in the top left corner. It's a bit like the edge of that inflatable one. It's a curved shape, and I like that idea of having a curved edge there. But it's just one piece of steel bar. The problem was when I did the calculations that the steel bar, again, it was expensive and heavy. So here's my calculation showing, engineering calculation showing what the force is, and 10 millimeters diameter, heavy and expensive, and I'm thinking, no, this is not going to work either. So I was telling a colleague at the University of Canterbury, and he said, why don't you use pultruded fiberglass? I had no idea what pultruded fiberglass was. I'd never come across it before. But when he told me, well, it's pulled, it's like it comes out of a toothpaste tube, but they pull it out. And I thought, well, that makes it straight, doesn't it? So it sets straight. Yes, that's right, it sets straight. Well, I want it curved. I want that curved edge. He said, well, why don't you find a way of making it work while it's straight? And I thought, oh, damn, maybe he's got a good idea there. So I had a look into the fiberglass, and sure, fishing rods are made of fiberglass, and they're curved. And the pultruded fiberglass found was lighter than steel, and that was one of the problems, was the weight, but stronger, typically stronger than steel, which is pretty interesting. And actually, we make it in New Zealand. In Gisborne, in fact, there's a company that makes it. And so there's some pictures of pultruded fiberglass there. So then I started thinking, now how can I use this pultruded fiberglass? So there's my first idea. I'm going to, here we go. Here I've got some pultruded fiberglass. I'm going to stick it into the ground. I'll stick it into the ground, sloping out like that, and then I'll put the mat across the top, pull it in like this, and we'll just plant them all around in the ground. And then we'll put the mat on the top, pulling in like this, and we'll have a trampoline. There's a difficulty with that. I mean, what if this is sticking up and you land on the edge? You might impale yourself. Not a good thing to do on a trampoline that's supposed to be safer. So, no, don't like that idea. kept on thinking, and after a while I came up with this idea here. Oh, what if instead of it sticking straight up like that, what if I lay it over like this, and then if you land on it, it'll bend down. And if it's still pulling in towards the center like that, so I could have it kind of like this, right round in a circle like that. Could I make a trampoline like that? And the more I thought about it, the more I was confused. I thought, I can't imagine in my head just how that's going to be. If you landed on the top, I could just imagine it going and collapsing or folding up like an umbrella or something like that. I thought, I'm going to have to make one. I can't give this to a student without making one. So went into the shed, drilled holes in this piece of wood and got some kebab sticks. And when my wife was out, I got a bit of an old sheet and sewed it up, and you can see that the sewing is not very good. But nonetheless, it was enough so that by the time she came home, I had that little trampoline there. And if you drop something on it, here it is here, and if I drop this on it, it actually does work. And that's just kebab sticks. Kebab sticks are not, you wouldn't think they're very bouncy, but there we are. They were very, very precious, very precious. They didn't want to bring it out of the case in there. But knowing that it worked, I thought, okay, we can give this to a student to make over summer. So that was the second lot of funding that I had, both at the same time. So those two trampolines were getting made together. So here's what he produced in the end. He had quite a lot of trouble getting the pultruded fiberglass to work, largely because pultruded fiberglass, you can have more or less glass in it. And we bought some pieces, we tested it, found out what it could cope with, bought a whole lot, and then as soon as we started putting the trampoline together, they kept cracking, breaking it. And then went back and said, why is this happening? And they said, oh, it's just a different amount of fiberglass in there. Did you want the same amount as you had before? Yes, we did. So here it is. We eventually sorted that out. And we decided that we really had to make the mat into sectors like that. Stupid idea. Didn't really make any difference. We decided it was very important and went to the trouble of doing it. And I never did that again. And in the edges there, the rounded edges, we had those pieces of alkathene pipe and things that would attach the end of the rod and connect them properly to the mat, but they were pretty crude. So from there, I thought, right, I've got 3 trampolines now. I've got that inflatable one, and I've got that horrible one that really is the worst bounce ever. And I've got this one here, which the bounce is not too bad. It's time to have a commercial relationship. Well, the University of Canterbury had Canterprise, so I went along to Canterprise. They were the ones who were going to get the commercial relationship going, and they said, what do you want? Oh, well, I want to talk to a trampoline manufacturer. Well, we're doing big stuff here. Oh, okay. So I went and looked in the yellow pages, and I found the person in New Zealand who was making the most trampolines, the biggest company, probably the only one in the yellow pages, in Levin, 600 trampolines a year. So I contacted the guy and said, I've got 3 different sorts of trampolines here. Would you be interested? Yes, we'll be in Christchurch. Send us some photos, and yes, I think I'll come down and have a look. So he came down and had a look and said, yes, I think we can do something here. I like that inflatable one, but not as a trampoline. I just want it as a pool toy. Could I use it as a pool toy? So we had a deal on that. He never paid me anything, but he took the idea and made it into a pool toy. He said, I hate that one with the white sides on it. There's just far too much fabric in it. That one with the rods on I like, but it's got a few problems. It's sort of, we need it bigger, and you can't have it low like that because you might think it's safe. It's got to be high, it's got to be dangerous, it's got to look dangerous, it's got to feel dangerous. And then it's got to break down into packaging so we can package it. And then it's got to be made so it can be assembled by a solo mother with no tools in half an hour on Christmas Eve when she's had a glass of wine. Okay. Well, I'm an engineer. I hadn't thought of any of that stuff. So I've put in here this the little box on the right. I was starting to learn about how you take products to market. So that little box on the right there has got, have I got a thing here that I can point with? Yes, I have. It does sort of work. I imagine taking a product to market as you've got a stool with 4 legs on it. If you take one of the legs off, you might be able to sit on it for a while, but it'll fall over sooner or later. So that one leg's the technology, and that's okay, I understand that, I'm an engineer. Technology, that's good, I'm good at that. But market, this is what this commercial person is. He knew about the market, I didn't know about the market. Solo mother with no tools in half an hour, I didn't get. Business, I didn't know anything about business, and finance, that's how you get money to take it to market. I had no idea about that. So I had one of the legs, and I was just trying to build a connection with the next 2 of them, and I wasn't doing it very well. Okay, I got the the student who'd made one of those, and because I was working with business, government would give me some money, and we got enough money to pay that student for a year. He spent most of a year to make a trampoline that was bigger and higher and could be broken down, and you can see it's broken down, and no one would like to receive a trampoline like that, but it did break down for packaging. And you could assemble it. But the edge fittings, we had 6 different edge fittings in that one because we couldn't decide how to actually do it. It was really quite complicated, but at least we had a sample. He said, right, that's very good, but I'm not selling that. We've got to have some market trials, and you've got to make the edge fittings properly. So I was moving on, trying to make the edge fittings properly. So well, this went on for several years, and one of the years, he said, right, we've got to have 5 of these things, and we've got to get them out to customers. We've got to get the feedback from the customers. So here's one of them in our backyard. It's got nice plastic edge fittings on the edge. You can't see them. About this time, Canterprise at university thought, oh, this guy's doing some commercial stuff. Perhaps we better get involved and see what's going on. So they came along and had a review, and here's the Canterprise review. I was very optimistic. I thought, here we are, ready for market. And they thought, this is not market ready. It's going to cost you about $75,000, $100,000 to take this to market. It's not there yet. Goodbye. And off they went. I was devastated. I thought it was almost market ready, and they just walked away. And okay, well, they weren't all that bad. What they did then, Canterprise went away and they hired another guy. In fact, this guy down here, he was someone who'd taken product to market before, and he actually knew how to do it, whereas I don't know that the people at Canterprise actually knew. And he put a lot of work into it, and he found someone who was prepared to invest in it. He looked in New Zealand, and there was really no one in New Zealand. He looked in Australia and couldn't find anyone there, but he found someone in Canada, a Canadian investor who was prepared to invest in it. And the Canadian investor did his homework. He was very reluctant, but he got one of these trampolines. We sent it over to him. He got his daughter to jump on it, and he said, so what do you think? And she said, I think it's rather cool. Oh, no. He said he really was pretty reluctant. But then he did his homework. How big is this market? 700,000 trampolines a year. I don't need much of that to actually sell quite a lot of stuff. So he decided he was in to make a deal with Canterprise. So shortly afterwards, he signed a deal with Canterprise, and he owned the patent from then on. As soon as he signed the deal, he came to me and he said, right, you've put a lot of work into these trampolines. You have to accept that maybe you'll have nothing to do with trampolines ever again. It's mine now. Do you understand that? Oh, shit. Took me a little while to get used to that idea. And then he said, okay, you've got that idea. Well, I need help. And first thing I want to do is change everything you've done. I want round tube. I don't want this agricultural stuff, galvanized tube. We can't have that. And I want the rods. They can't be welded on the outside. They've got to be stuck into the tube. And I know it breaks down for shipping, but it's got to break down into smaller pieces for shipping. And so everything had to change, and I couldn't argue with him because he owned it. We worked with him and got a trampoline built. This is the first golden sample, we call it, is the first one to his specification. We eventually got it to hang together with breaking down into 6 pieces. All right, I'm going to take a little segue here. Parallel with the development of the trampoline is the development of the edge fittings. They were the hardest part. So there was another whole little innovation train going along in the background through this development. So right at the left-hand side there is the first edge fitting. I was very proud of it because it's the first injection molded plastic part I'd ever designed, and it was really cool. You could assemble a trampoline 90%, 89, 87% finished in way less than half an hour. It just took about 3 hours to get the last 3 assembled, 3 bits. So that was the one that wasn't ready for market. They were right, actually, weren't they? But I thought, I've got to do better than that. I mean, we've got to be able to assemble it more quickly than that. So the next one, 2001, is one where actually it was much easier to assemble. So I paid for another die. It cost a lot, took a long time to make and then we got all these cleats. You couldn't just get one. You needed a whole trampoline's worth to be able to put it all together. So it's the one just at the left of 2003. And when we got it, we made a trampoline mat, we put it together, it went together really easily, wonderful. I got one of my postgrad students to bounce on it. It came apart really easily. You jumped 3 times on the trampoline and it unzipped itself and the mat was on the ground. Not successful. Oh, I spent a lot of time trying to figure out how to fix that and thought, no, we have to start again. So another plastic die. So that's the next one, the right-hand one in 2003. It's now a ball and socket joint. So we have to have a ball, another piece. Now I've got another piece. As an engineer, you don't want to have another piece. That blue ball there was connected onto the end of the rod and it fitted into the socket. I think I've got one up here, and I'll show you later. Well, that was really successful. That fitted together well, and we made some trampolines like that. The investor came over from Canada to have a look, and we went to Levin, where we had the trampolines, and we were showing them there, and the man in Levin who was in charge of it said, oh, by the way, we just found out kids love bouncing around the edge of these trampolines. They play all these different games now, but if they just jump on the edge in the right way, the rods will pop out like this. Oh, no, that's the worst thing. This is so dangerous. I mean, what if a little kid, 2 years old, is running along and this thing pops out and hits them in the eye? My daughter said, Dad, how many rods have these trampolines got? 90? She said, that's a lot of eyes. And the investor said, we haven't got a product. So the most intense period of design in my life occurred then. And I had to design something new, which is by the blue ball there's the same ball and socket joint as on the start of 2003, but it's now got a clip on it. So this one here has got a little clip on. It'll go together like that, but it won't come apart. And the little clip, you have to pull the lever there, and then you can get it out again. It took a lot of work. That's the little red thing there is the clip. I was so ashamed of myself. That's now 3 parts, and somebody in the factory would have to put that in. The first time I put that little clip in, it took me about 20 minutes. It's really hard to get in. It was clever design to get it designed so that it would work when it was in there. It was really hard to get in. And then we had to test it to make sure it worked. So here's the testing. In the night, intense design. But eventually we'd got it so that it wouldn't come apart when somebody jumped on the edge. So that's William. He's a bit older now, 13. He was the best person in the world to jump on the edge and get them to pop out. And he was so frustrated when he couldn't get it out, but we were so pleased. The other thing the new owner wanted is that he wanted an enclosure, a net around it. There'd been someone had fallen off a trampoline in America, broken their neck, and they tried to sue everybody, and the people that were successful at suing was the retailers. And as a result, no retailer in the US would sell a trampoline without a net. So we had to develop a net. And the new owner said to me, the investor said, you have to make it out of this fiberglass rod because we've formed a relationship with a company that sells fiberglass rods. The fiberglass rod is really stiff. I said, no, it's not. It's really flexible. He said it's really stiff and you've got to use it. And I'm thinking, no, this is not really stiff. Well, I said to the postgrad student, we're going to have to do it to prove it to him that it's far too flexible. It's not going to work. So that's what we've got there is the student saying it's pretty bendy. He put sockets in, he put 12 of them up, he tied the tops of them together, and then kids being kids, they wanted to play on it, and he hadn't even finished doing it. So here's my daughter playing on it here, and then she does this thing, and you go, oh wow, hey, that's pretty interesting. Well, it does support her weight, doesn't it? What's going on here? Maybe the investor's right. Maybe those bendy rods were going to be a good idea after all. So the next week he had to go looking for fishing net all around town, finding some fishing net, tying it on pretty roughly. But by the time that was tied on, then when the same naughty little girl got on the trampoline, hey, that was pretty cool. Maybe we've got something here. So I had to go back to the investor and say, yeah, that's a really good idea. They are pretty bendy, but that is actually quite a good idea. Subsequently, through 2004, we started production. And then we found there's a real issue with these nets because they're knitted, and anyone who does knitting knows that you have to get the tension right. If you don't get the tension right, you can get things to be really baggy or too tight. And that was something that the net-making people had never done before. They never bothered with this. So I had to try and figure out how to decide what was too tight and too loose and do something about it in the factory. So here's finding one that's too loose, and this is what happens. So you end up on the ground. And well, while it could be quite exciting getting back again, because you could actually get back without help, that wasn't tight enough. We don't like it that loose, because people falling on the ground like that complain. I developed a test. I wanted some sort of instrument that could measure what the right tension was, because I had to go and get this tension right in Toronto, where the factory was. And this is the test that I developed. It's called the Super Undignified Net Tension Test. If you could actually get your toes onto the edge of the mat, it meant that it wasn't too tight. It was too tight, you couldn't even stand there, it would just be pushing you backwards. If it was too loose and you leaned into it like that, you ended up on the ground. But if you stopped at about 22 degrees, it was around about right, and it took quite a lot of getting that. But we got the factory eventually to be able to test it. As it came off the knitting machines, they could test it and they could adjust their tension to suit. So the whole story with the net is we ended up with unexpected capabilities with the net. It actually became a new play feature, and that's quite a selling point. And in fact, kids being kids, they do stuff. And even just a couple of weeks ago, we had kids get on a trampoline and do this, and I'd never seen it before. Just like that. I'll do that again. So, kids will explore things like this. You give them stuff and they'll explore things. Anyway, back to 2004, we're still trying to get the production started. 2004 was my sabbatical year, and the investor asked me to help with production in China. So I was 5 times up to China and up to Canada a couple of times. And he wanted patents on every new feature. He said to me, "You've sold me a patent, one patent, and it's only in the US. I mean, what happens in other countries? Look, we've got to get more patents. Every new thing that you make, we've got a patent." So here's the patent of one of the other edge fittings. The other thing that happened is that in the US, we weren't going to be able to sell in the US. You couldn't sell in the US because the US trampoline standards said that a trampoline, when it's offered for sale, has to have frame padding. Why did we need frame padding? We didn't need it at all, but the standard said. So if we were in court, if there was a court case there, they'd say, "Does your trampoline comply with the standard?" No, it doesn't need to. Well, if it doesn't comply with the standard, you must be at fault, so we're going to sue you. So how do you work with a standard that sort of excludes you from the market? Well, what you do is you go and join the standards committee and you propose some changes to the standard, and you say it nicely and they let you do it, and then you change the standard to suit your product. So that's what happened. I've been working in the standards committee in America ever since, changing the standard to make them safer. 2005, this was a milestone for me. Here we are. Look at this. In Quebec, there's a Springfree Trampoline in Quebec. My invention. Wow, that is really cool. And then in 2010, we had this thing happen. Wasn't just happen, a lot of people put a lot of work in. US Product of the Year. So we actually have got somewhere, made a big impact. This is pretty impressive. I thought I was quite proud of myself. Campbell Live likened it to refrigerated shipping in Hamilton jet boat. I think he was getting a bit carried away because Campbell Live used to do that. I really like what the Bluebird Potato Chips said. They wanted it in their Kiwi As campaign. They didn't ask Springfree, they just started doing it. Bluebird Potato Chips, Kiwi As the Springfree Trampoline. That was pretty cool. 2014, as David said, was a patent defense. I found myself sitting in a chair at a large table looking down a street at a White House. And it was the White House in Washington, D.C., and I was freaked out. And I was freaked out because the guy who was coming to see me was a top US patent lawyer, and he was going to be telling me what to say to the judge the next day, and it was my first court case. And what this was all about was my core patent that back in 1996, maybe I did something wrong that meant against American patent law that would undermine this whole company that was supporting 325 people or something at the time. And as I sat there looking down the road at the White House, I thought, actually, how many products have got from New Zealand to the US to be vended in Washington, D.C.? Isn't this amazing? Aren't I a really privileged person? Isn't it an amazing team? We couldn't lose. I felt really overwhelmed with what a privilege it had been to work with the team to get us there. So for me, it was a no-lose situation. It didn't matter. We didn't win that case, but we didn't lose that case either. Just like American law, that's the way it goes. But the thing that I learned from it, even though it was $1.5 million, I kind of learned that regardless of whether you win or lose in court or whether you feel privileged or not, where you really got to win is in the market. So, back to the market. Where are things up to now in terms of how is it done in the market? Well, it grew and grew until it was something like 30,000 units a year. It's been up and down, around about there for a while. It's currently selling into 25 countries. Springfree has its own factory in China, which is a huge achievement. You don't realize how hard it is to set up a factory in China and how risky it is. People say, oh, well, it's made in China. Well, that's not New Zealand. You know, you haven't done much for New Zealand. But in fact, there's 25 containers a year from Gisborne, who still manufacture the fiberglass rods. That's 500 tons a year of these things. 500 tons of this. That's a lot. And then there's 90 tons of these plastic fittings a year go to China. So about 40% of the cost of the product is made in New Zealand. So that's where we stand at the moment. As I said, it's been hovering around 30,000 or so. So if you look at the typical product life cycle, it's a sort of S-curve like this. Starts off slow, improves rapidly, and gets to some sort of stasis. And we seem to be around about the top. Now, what do companies do when they get to there? Well, often what they do is try and reinvent the future. They try and invent something else that they can add to or improve the product so that it's going to go further. And this is where I hand over to Doug, because in 2011, he was already thinking of that sort of thing. Okay, so I'll now hand over to Doug, and he can tell you the next bit of the story.
Thanks, Keith. Am I on?
Yes.
It's not often you get two good-looking bald guys in one night, I guess. So that'll be a good start. Just an aside to any of you who are innovating or in business in general. We don't tell Keith everything, but I was driving home the other night listening to national radio, and on the business news they were saying that Fisher & Paykel Healthcare had just announced a bumper annual profit. They were in litigation with a big U.S. company, and just to set the litigation up, in the last 12 months they'd spent $21 million. That's just to set it up. And the sort of number Keith described was sort of our setup costs. And we didn't win, we didn't lose. So, patents, IP, how it's managed, it's a really, really interesting, risk-laden game. We have been very strong on it. We're highly committed to it. It may be one of the reasons we haven't been knocked off over all the years that we've been in this business, but it's not simple. A lot of guys think they're going to get a patent and it's going to be a great idea. Go get some advice. I don't know if you have ever seen that movie, The Shawshank Redemption, but there's a line in that I've always loved, which is, you got to either get on living or get on dying. And it's a little bit like that in business. You start a business, you build it, and as Keith described, you get to various plateaus, and sometimes it's easy just to, you're making money, things are going okay, life's okay. What are you going to do next? How are you going to ensure that your business survives and carries on? A friend of mine sent me something, I'd never read them before. Apparently Jeff Bezos, who runs Amazon, publishes his letter to shareholders every year. And he sent me this past year's letter to shareholders, and it was really fascinating. And it was headed up something like, let's try and stay as a day one business. And he said there's two kinds of businesses. There's day one businesses and there's day two businesses. And I've been an entrepreneur for a long time. I've started 9 companies. And, you know, in the early days, they're all exciting. You know, you've got a whole bunch of usually young people. Everybody's enthusiastic. You work all night, eat lots of pizza, drink lots of beer. You find out lots of new stuff. And then if you survive and you succeed commercially, you get bigger, lots more structure and process happens around things. And all of a sudden, different things start to matter. And instead of thinking about your customers often and the market and your competitors, you start maybe wondering about, you know, who's got the best office, or how come somebody else has got some more stuff than you, and all those sort of things. And he was basically saying those are day 2 behaviors. And I guess that's something that it's been easier to not fall into that trap around Keith Alexander. If you go to Keith's house, he's got a bald spot examination device that he has on his wall. He's always full of crazy ideas, but we're always watching and listening and thinking about what we might think about next. And as Keith said, as we've grown the business, we're not an easy product for a lot of families to grab a hold of. We're a relatively expensive product. That's partly because of the nature of Keith's design, you bad guy. But it's interesting, as he said a few moments ago, 40% of the manufactured value of the trampoline is still made in New Zealand. It's a very, very expensive product to build. It's a fantastic product. But we've never, to this point, managed to push past sort of that 5% market share. And so we began asking ourselves, what could we do, what might we do to change that? One of the things that Keith's always encouraged me and lots of people to do is listen to people around them, people who are interested in what you're doing, and if you've got customers, observe them. You know, market research is a terribly flawed thing. You ask people questions to get information, and you get all sorts of strange responses. And often they're quite counter to what people are really thinking and feeling. And there's no better way to get to the truth of a matter than observe how people behave. And Keith's titled this Moonlight Lady, but one day I was walking into the office. We had our demonstration trampolines sitting around outside. A lady came in to buy something, and she gave an instruction to her 2 children who were around about 9 and 12. And she said, "Get on the trampoline and play Moonlight while I go inside." We don't often hear that, so I thought that's an interesting thing to almost command her kids to do. And they climbed up on the trampoline and they began to play this very elaborate game. And I mean, it was elaborate. And I said, "Wow, that's amazing." And she said, "Oh, that's nothing." She stopped, kids, and she said, "You know, show the man this." She didn't know who I was. And they played another game. And I said, "You know, that's fantastic." She said, "Well, you know, they get bored jumping, and I send them out there and make them stay out in the backyard, so they've made up these games." And I guess that started us thinking, could we somehow turn this platform into something no one's ever used it for before? We saw this wave of technology happening all around us with kids on computers and gaming. We saw friction with parents, and we thought, could there be some kind of technical solution that might allow us to effectively liven up our jumping surface and allow kids to use it in a way that hasn't happened before? And so we began an investigation. As David said earlier, it's really interesting. And New Zealand is an interesting place in terms of the way we sometimes do things and embrace some of these problems. We've built this thing we call Tagoma, which is an acronym for Take Gaming Outside and Make It Active. We couldn't patent the core idea because a US company in about 1997 had sat down. We reckon they got about 10 cases of beer and spent a weekend locked up coming up with every crazy idea you could think of that had anything to do with a trampoline. And they had like a 400-page patent. And most of it was rubbish, but buried in there was you could create an interactive jumping surface by attaching sensors to a trampoline mat. And there it was, prior art, not something we could patent. What's interesting is it's really hard to do, and no one had ever actually tried to do it. And so I was sharing this with Keith one day, and he said to me, well, there's a young guy at the university here who's working on something that he calls time of flight measurement. And he's a gymnast. He's an electrical engineer. Not a great student, I think was Keith's observation at the time, but persistent. And you should talk to him.
Should have said that.
And it was one of those crazy examples where here was a guy who wanted to measure the time of flight of a jumper, how long they were off the trampoline mat. There were some crude tools that you could buy that were incredibly expensive. John didn't have any money. Keith didn't have any money. We thought it was a little bit of a crazy idea, so we weren't sure how much we wanted to invest. And here was a undergrad beavering away, trying to figure out with virtually no resources how to solve a problem that in fact the competitive trampoline world was trying to solve at the same time using a lot of more money and technology. So it was one of those things where somebody with very little to work with came up with some concepts and ideas that the people with all the resources hadn't thought of. Basically, we had to come up with a sensor system that we could attach to the trampoline surface and that would somehow calculate your jump location and height, transmit it to something that could process it, and then take those calculations and interface with some software that you could effectively engage with and have some fun with. And this story, we haven't described it in the same depth as Keith has in terms of his tramp invention, which actually happened over quite a few more years. But it's the same process. You're never sure what's going to work, and you're never sure if you can get there. We tried a whole range of different technologies. Saying to Keith today, it's interesting, I still can't think of another type of product except very heavy industrial robots that use sensors and data communications outside 24 hours a day, 7 days a week, 365 days a year, other than this. So I can see them in the timber processing industry and in the mining industry, in a whole range of heavy industrial equipment uses. Beyond that, it's just too hard to keep sensors working in all humidities, in all temperatures, to keep a data cable that works when it's physically deformed grossly, repetitively, that doesn't fail. It again, has been a really challenging and difficult exercise. Once we got a system that actually we could get a signal working, we had to figure out how to make a trampoline mat look like something to a piece of software. And there was only one way to do it, which was to brute force it, I guess you'd call it. Basically, to get jumpers, you got a picture there, Keith took this secretly, I guess, and we hired a bunch of unemployed students. We hired this one mechanical engineer, right, Sam, and he's amazing. I guess he's an okay engineer, he's got a job now, but for a whole year, all he wanted to do was do that. He's the guy in the background with the red hair, and this guy was amazing. If you've tried to jump on a trampoline, and you could, you maybe do it for 15 minutes, maybe if you're really, really fit, you could do it for 30. This guy could do it all day, and he'd do it day in, day out, week in, week out, and for some reason he didn't get bored. But effectively, we had to map every trampoline that we make, we had to map somewhere around 120 points, some more, some less. And the only way to do that was to create a system it's kind of funny if you saw it. It's the same story as this. Those people have all got tin foil. We call them magic socks. So they're tin foil socks. What we would do is we would effectively create a bounce location with two capacitors, I guess they are, and effectively when they connected with both of those simultaneously, you created a circuit and we got a jump. If you jump like that, it wasn't a jump. If you jump like that, it wasn't a jump. They got very good at being able to jump like that. By the time we finished that, it had taken us, it was a year of calibration. We had to figure out what a jump looked like. We had to try and understand when you impacted the mat, when you left the mat, and when there was an artifact after the jump of the mat going like this, how to decide whether that was another jump or whether it wasn't. So huge amount of data processing going on. I guess, again, something else David said, none of this happens in a vacuum. We were stumped several times. There's a lot of smart people in New Zealand. Before I was involved in Springfree, I was involved in the data communications industry. A bunch of you have been around. If you're old folks, you might remember something called the DSIR. In 1991, I bought a group out of the DSIR as it was melting down and being reformed into CRIs. And it was a bunch of guys that had been working at Gracefield and Wellington. Nobody knew what they were doing or understood it. And they had actually built a lot of the building blocks of the internet. And that happened in New Zealand. And we went out and we fought against Cisco for a few years until they kicked our ass so high and hard we had to sell out. But we got to a bunch of places that we didn't know how to get around. And we pulled in some of these signal processing experts, global scale, global quality people who basically helped us get through some of these gates that we were just stuck at. There's some videos here, but they're not that great. Everything we've done, we've tried to do as well as we can. There's a little bit of a, don't know what you'd call it. There are people suing people like Fitbit and Nike, Garmin right now, the activity trackers that you can buy, how many calories have I burned today, that sort of thing. I recall at some point it was in the New York Times where there was a group of 13 Americans who all went on a tour somewhere in the world, and they all were wearing Fitbits. I think it was Fitbits. So they all said, let's compare. And there were 13 different answers, wildly different, about how many calories they'd burned during the course of their walk on a particular day. One of the things that's great about working with Keith, it's not easy to find good people, and Keith's a good people. And he's not just a really nice man. He's a very, 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 very thorough person. I was going to tell you a little dirty story about Keith. I think I will, just for a laugh. It's not really dirty because he's not a dirty guy. But when I first met Keith, he was pretty excited, and you've gone through the whole, you've seen some of the story, and he generates data like crazy. He's the sort of guy that he will measure things and remeasure and remeasure. He's got spreadsheets that, would fill these walls. And one day I was in his office in the early days, and I was asking him to explain to me why he thought he needed a particular number of rods in this design. And he pulls out this spreadsheet, and the file name was The Experience of Stiffness. And the man is such a pure-hearted fellow. I said, "Why would you call it that, Keith?" And he said, "What?" And that's the kind of guy Keith is. But we were looking at how do we engage people with this new technology we've built. You can do something on a trampoline you've never been able to do before, and why don't we're going to have to build some software. What can we do? Well, we can build games. We'd like to have a crack at maybe some educational stuff. Well, fitness seemed to be a natural potential path. And Keith said, "Well, if you're going to do it, let's do it right." And here's an example. You know, we've got people jumping, we're measuring CO2 production in the jumpers, and basically we've got a system that's within
12%.
12% plus or minus accuracy, and it's consistent. And if you want to know how many calories you're burning on a Springfree trampoline jumping using this software, well, it's not bad. Tagoma has been interesting, and it is interesting, and we're right now as a business very much in the crossing the chasm moment with Tagoma. We've built something that the market doesn't understand. You buy a trampoline to jump on it. You don't buy a trampoline to game on. You don't buy a trampoline to learn how to spell or do maths. And it's been a fascinating re-experience. You know, I think David said something about it before, you know, but it's that old saying, I don't know what I want, but I'll know it when I see it. And you try to explain to people what this is, and most people don't get it. Let them play on it, and we've got an interactive display upstairs, and they go, oh, that's so cool. Wow, I never thought that could happen. It's really hard to do something that's the first of its kind. And just like with Keith's trampoline, people used to say to us, where are the springs? There's got to be some springs. Where are the springs? They didn't get it. We're having the same challenges getting this product into the market. We're doing okay. I took some heart. A couple weeks ago, Rod Drury was quoted on the 10th anniversary of Zero, and he said, oh, at the end of year one, we had 1,000 or 1,300 users, and we were all depressed, you know. And we've done okay. We've been in the market a year. We got 6,500 people using it, and 150 new users every week kick the thing off. It's kind of interesting. That's kind of the curve of uptake that we're seeing around the globe with this product. But it's a challenge, you know. We've got coming up to 7,000 users. We had to build 30,000 of them in a first run effectively to get the volume and the cost envelope that we needed. Just an example, you know, one of the whacked things about digital technology is, you know, the connectivity it provides you and the insight it provides you. And we're starting to be able to look into for the first time, that's crazy as a trampoline company, into our user base, see what they're doing. I don't know what else Keith has put in here. That's about it. But, you know, we can look at what apps they're running, how many jumps they're doing, you know, what people's preferences are, how long before they get bored. All those things are feeding back and informing our software development. And I guess it's the same for anyone who's in that game. So yeah, where is it going to take us next? We're not sure. But what we believe is it's the potentially next opportunity for us to take our market share to a place we haven't been successful in getting so far, and what we think the product deserves. You know, everybody says to us, we'd like to have a Springfree trampoline, we're just not sure if it's how we want to spend $2,000. This appears to be changing that algorithm a little bit for us. I'm going to let Keith come back up, because...
Just click on the last one.
Oh, see, I went too fast.
Yeah. Just finish with the thing.
Faith, Keith's wife, is a great lady, and I guess she's like a lot of our wives. She's probably quite surprised on how things have gone, but a supportive one, and we wouldn't be here without her. But did you want to finish with anything, Keith? Or, you know?
That'll do. We can finish there.
Cheers.
So thank you for showing us that tenacity, and that really, I think, speaks to one of our points so beautifully about this idea of overcoming obstacles. And I think taking a court case or surviving a court case in the US is probably one of the largest obstacles any of these groups have addressed. But I want to invite you to speak about doing this from and in New Zealand, and how you think, going back to our theme about good remoteness, New Zealand personalities, New Zealand conditions, New Zealand's can-do attitude, and how that has influenced you for good and for bad through this process, and also whether you've recognized any changes over the course of your entrepreneurial careers.
Well, I was born in New Zealand, so this is just the way we do things here. I think being at engineering school in New Zealand, what we find is that if we get overseas people compared with New Zealand people as students, we find the New Zealanders, especially if they've come off the farm, have got a way different can-do attitude. And I think it comes from our pioneer heritage that because New Zealand has been so remote for so long, we just know that we have to do it. We have to do it ourselves. We have to figure it out and just go ahead and do it. And it doesn't matter if it's hard, we figure out a way of doing it. So I think that's one of the big advantages. I think if you're in Europe and you've got lots of other people around you and a lot bigger population, there's a lot more regulation, I think it shuts that down. So I think that's one of the things, is just the pioneer history that we've got is one of the things that contributes to our opportunity as New Zealanders to be innovative.
I don't know what our demographics are in terms of rural versus urban, but I think that I emigrated to New Zealand when I was 21, 40 years ago. One of the things that appealed to me coming from Canada was the fact that the outdoors was everywhere, very near. I think that Kiwis have a little bit of a natural advantage because of that outdoorishness. That's a word we just made up. And the reason for that is that you create your own content. So you're not getting someone telling you what to make or how to make it or what to do when you're in those environments. And even it's as simple as the beach. You go overseas, it's different. You know, you live in a large urban area in North America, life is formatted quite a lot more. And so I think that has an impact. I know what Keith said, I've experienced regularly. We always like looking for young engineers who are interested in fixing up old cars. Getting an engine or a transmission rerunning is a challenge, especially when you got no money and few tools. And that sort of problem-solving approach that starts when you're 15, because you know you can't afford a Mustang, you know, like they can, you know, over there. Seems to make a difference to the way people engage with a problem.
And from your experience, do you think that the next generation of Kiwis, and bear in mind we're creating here an exhibition in MOTAT specifically aimed at inspiring the next generation of innovators. You know, although we're using your story as a tool to hopefully spark a set of responses from others, from excuse me, a younger generation. That younger generation don't experience the same remoteness, in the sense that, excuse me, digital products that are available in the US today are available in New Zealand today, almost simultaneously, and things created here are in other markets straight away. So from your experience, are you finding that Kiwi innovation and those sorts of qualities, are they under threat, or do you think that that can be encouraged, that we can maintain that sense of, well, I don't know how I'll do it, we'll make it up?
I'm not. I worry as a lecturer that we're going to lose it, and that they depend so. The students now depend so much on the internet. They don't really know what a library is for, and all the good stuff's in the libraries, and the good stuff's getting on the internet. But there's still so much good stuff there. That worries me a bit. But then I'm an old guy, so I'm going to think like that. Yeah. I just, the things that drove us was the isolation. That you can't. I remember I was trying to make something with my Meccano, and I wanted something that you couldn't get, which was a rotary plug, so you could plug something into the wall, and if you had a vacuum cleaner, and you'd go round and round in circles, and it would turn, and you couldn't buy one of those. and I couldn't make it either, and I was really disappointed because I almost expected, all right, if I can't buy it, I should make it. But I don't know that people would do that now. I don't know that I wonder where that attitude is if you just have to go on Google it, and you'll be able to get it there, you get it on Alibaba. That seems to be a disadvantage. So I'm not quite sure how we encourage people. I think you're doing the right thing here by saying people of your personality can do this sort of stuff. Just trying to encourage the can-do attitude, I think, is a good thing.
And if we had your colleague, John, who I think it's fair to say is a different generation.
Yes.
He's a younger man. Would he have a similar attitude? I mean, he's clearly demonstrating a lot of that. He's clearly, he couldn't measure time of flight, so he was heading out to try and measure it himself.
Yep. That's a typical New Zealand thing, rather than, I'll go on the internet and find it. Yeah. So how did he get that? I'm not sure. Not sure how he got it.
Yeah.
You mentioned earlier Rutherford. We didn't have money, so we had to think. I think there's a lot of, inventiveness and innovation driven out of need, and a lot of that's economic. I think that we may be able to, because we're actually a relatively we are a poorer country than some of our fellows, we don't have the vast resources of the US or some of the European countries. So you go to, Keith teaches a curriculum that's a little bit different, and they have a lot less resources than he would find if he was at Caltech or places like that. There's probably some native benefit to that, having to eke it out a little bit.
Yep.
And we may retain, in the face of this homogenization, some of that difference, just purely, we're a small country with a small economy, and it's harder to get resources here, and that may help us in the long run.
Yeah, I like which is the good remoteness thing. If being small and actually not having it may be ultimately to our advantage. Yeah. Can I throw it open to the floor? Are there any? A few straight away, right at the back. First hand up, please. There is a roving microphone if someone could. Thank you.
Thank you so much. I'm truly inspired being a young entrepreneur and really embracing frugal innovation. This is very inspiring. But something I would really like to understand a little bit more is behind the concept of failure. Because in this country, failure is a definition of lack of success. That's when you Google what failure is, that's what it defines. And through my experience in my little years of running a small idea and a small business, through my failure I've been able to find opportunities and dig in more into finding different solutions. I saw that you faced multiple failures throughout wanting to develop this initiative. What really kept you going when the fiber sticks broke and the sockets didn't work out? What was the ignition behind all of that so you'd keep on going? Because sometimes, as a young entrepreneur, you face a challenge or you face court, for example, and you just want to hide away.
Thank you. Keith?
The answer to that's a very personal answer, so I'm going to evade it a little bit. But I will say that there was a strong emotional reason for doing it. And I think that's the crux of it. If you have some strong reason for wanting to do it, that drives you emotionally, that's what it has been for me. So quite a lot of people, quite a lot of things are like that. You find that there's somebody's just determined that they're going to get there in the end. That sort of determination, I think. I went to a conference that was about innovation in New Zealand, and they looked at a wide range of factors. They said, well, what helps innovators at different stages? So there's things like funding, there's availability of equipment, government support, and so on. They looked at all of those. And one of the things that came across to me as really important is at the very early stages of an innovation, it's the emotional support that's most important. So if there's somebody starting out with an idea and you said, right, we can give you $1 million to do this, that's not what they need. At that early stage, what they need is their mother to say, this is a really cool idea, or their mother-in-law or someone like that. So that's really why I put those those slides, that last slide, and that grandmother was really supportive, because that was a very important thing to me all the way through. That was a connection. There was a lot of tension between me and my mother-in-law, and yet the fact that she was encouraging was a strong motivation. That wasn't the only one, but that was a strong motivation. So those emotional things, I think, are the drivers in the end.
Thank you. Do you want to add any?
Well, just, I think, and Keith's right, you've got to find a way to give yourself that power to take that next step. And I think none of us do it, I don't think very many of us do it in a vacuum. I'm a hopeless optimist, and I would say that. And that's a wonderful thing to be. You know, I got a great poem that somebody told me years ago about me. It goes, "The optimist fell 12 stories. And at each window bar, he yelled to his friends who were frightened below, 'Well, I'm all right so far.'" And, you know, that's great until you hit, right? So I'm a wonderful guy to have on a team, but very often I don't see the ground coming. Now, that's a wonderful person to have around sometimes, because there's ground coming at you every day at 100 miles an hour, and if you're worried about it all the time, you wouldn't do anything. But you need to be in a team with people who go, "No, this one's serious, Doug. Like, this is going to knock us out." So I think it's that group of people that you have to get. You know, you need the enthusiast, you need the critic, you need the realist, you need the dreamer. You need people who can feed off each other and support each other when they're out of sync.
Thank you. I love this question, and Doug, your answer in particular leads me to recognize and thank that all of our innovators were very kind when we asked them to take a personality test and share it as part of the exhibition. And when you go around, you'll actually see that the personality tests are all on the wall for everyone to see. And that was quite a big opening up for each individual to be able to take us what are quite personal questions about who they are and what they do and don't do. And of course it reveals, some people phoned me up and said, "Oh, I don't think this is quite right. It made me look like I'm really outgoing, but I feel really shy." And actually we recognized that their personality was probably not what they perceived themselves to be. But we saw a real range of personalities. There was the second question here in the middle.
Yeah.
The microphone just go.
I was just interested in the line, "the safest trampoline in the world," and if you managed to weave that into your promotion and advertising as well as Springfree.
We got sued on that one too.
I would never say that. I would never say that. He's the one who says that. That's the tagline the company decided to have, "the world's safest trampoline." I thought, this is wrong. I can't say that as a researcher. They wanted me, I went to Toronto and we did a week of videoing. They wanted me to say, "You've got to say this. This is it. All of us here, we come here in the morning because it's the world's safest trampoline. You've got to say it." No, I'm not saying it. I'm a researcher. I can't do that. I'm a professional researcher. I cannot do that. And we had this tension. Doug and I had this tension. It went on for 6 weeks before he actually said, "I get it. A professional researcher cannot say, without the evidence, cannot say things like that." So the company put that there. The stupid thing was that our competitor took us to the advertising court in America and said, you can't say this. And so I got the job of justifying it.
He did a great job.
Damn it.
Yeah, that was last year. We've used it for years, and somebody, decided to have a crack at us. And, there are global advertising standards for making claims about being the best. And, we hadn't done a double-blind, placebo, effectively the only way they were going to let us use that in the US is if we had tested our product, which we'd done. They gave us accolade after accolade about being the only people on the planet who are doing any research, doing any, metrics. But if we were going to use that, we had to test against 80% of the competitive products, which was 1,000 different variants, and it just isn't going to happen. So we've had to back off that statement in our advertising in the last 12 months. In fact, they said we probably are, but they wouldn't back us.
Well, we had justification. We did the research. We looked at what trampoline injuries were caused by, and then we looked at how the Springfree trampoline compared, and we showed that the paper showed that the Springfree trampoline was at least 30% safer than the general population of trampolines in America, and more like 80% better than general population of trampolines in Australia. We had the evidence that was published in peer-reviewed international journals. So we thought that's pretty good. I really wanted to validate that it was a safer trampoline, not the safest, not the world's safest, didn't matter to me. So we thought we had the information that kind of conveyed, we had the data to back up that statement. Not that I would have ever made that statement, but we hadn't just said it's the safest because we want you to buy it, and we have got no evidence for it.
Thank you. Another question at the back, this gentleman.
Hi, Stuart Kelly from Arditi College. I'm just wondering to what extent you think our education system inhibits or enables innovation.
Keith, that one has to be for you as a professional educator.
It depends on the kids. No, how much does our education? I don't think it's bad. I think there's quite a lot of good stuff in there. You just keep hearing new things that the schools are doing and cool stuff that the university is doing, and it's pretty exciting what's going on. They keep challenging kids, I think. I don't think it's doing harm, and I think quite a lot of, there's a lot of good stuff happening. So to what extent does it inhibit it? As a teacher, I'll blame the parents, if they're not.
Keith, I think that's a perfect opportunity to plug the next of these events, which is inviting the Mind Lab to come and join us on, someone tell me the date? 8th of June, thank you, which we'll be specifically looking at disrupting education in New Zealand. May I ask another question, which is about questions of ideas and ownership of ideas. Doug, you described and you touched upon, this was your invention. Sorry, Keith, you said your invention. You spent a long time thinking at it, going through all those iterations. And then there came a point where, through the university and the investor, that was no longer your idea. It was now owned by someone else. But that's an important part of the step of this becoming a product.
Yeah.
How do you feel about that sense of ownership of an idea and that sense of others then taking ownership and where that's influenced your story?
Yeah, I'm good to jump in on that one. So I have a bone to pick with the universities, most universities. So this is what, look, I work for the university, they're my employer, I've got to be nice to them, but the way the commercialisation arm of the university works and the way it's set up is it says, right, we own anything that you come up with that is potentially commercial. And I've told them again and again and again that the best way to kill an idea is to take it off someone. If you want the person to be motivated to put a lot of effort in, you want them to stay involved with it. But universities all over the world think that the best thing to do is to say, you've invented it here, so it belongs to the commercial arm of the university, and if we can, and we might help you out with some funding for it, but it's ours to sell. But there are some universities that don't do that. University of Waterloo in Canada, and some places rather more enlightened, and University of Waterloo is doing really well with its commercialisation. The feeling about it is really important. So the way I think of it for myself is if I've come up with a new idea, it's kind of like a baby.
Yeah.
It's mine, and every invention like the trampoline needs a mother, and you need, and I've described it like this, you carry it and you feed it and you introduce it to new friends, and you do that for years, and if you're really lucky, it will get to a place where it starts to make its own friends, and then it goes off into the world, and there is a time when it's best to hand it over.
Yeah.
So that baby analogy, I think, has been a good one for me. And so for the trampoline, it was time. It was time that it formed its friends away from me, and I could let it go. I could still help in the background, but I could let it go and make a life of its own. Yeah. With the team that were working on it. Does that?
Yeah, thank you. Well, particularly in the context of Auckland's making significant efforts to promote its digital economy, and there's a lot of startups in town, and those startups are desperately trying to get investment but hold on to their companies. So I think for the next generation of entrepreneurs, this idea of investment and ownership is a big one from day one. Any other questions from the floor? Stephen at the back.
You gave us a fantastic story in terms of how you prototyped and tested and iterated the product. What about the business model? I'm really curious as to, did you apply the same rigor to prototyping, testing, validating to get the business model right, especially as you're scaling into that many overseas markets?
I'm assuming that's a Doug question, given you said you don't know anything about business.
I mean, I think that there's lots of different ways to do things. I think, as Keith said, the beginning of the commercial program was identifying that there was a market opportunity, and it was a reasonably large one. This has been very much a story. Dave was sharing, Xero's startup story. It was very much. I still recall the first real commercial opportunity we got, which was with Costco in Canada. We tried to start selling in New Zealand. It wasn't working very well. The margins that everyone wanted through the channels weren't working. So my business partner was over in Toronto, and he calls me at 3 a.m. in the morning and says, I'm with Costco, and they don't take our price. And I said, well, go lower. So I hung up and went back to sleep. And about 5 minutes later, he phoned again, they won't take our price. I said, go lower. And that happened about 6 times. He said, we can't go any lower. I said, go lower. And basically, they wanted it to be sub 1,000 Canadian dollars, including taxes. And that was their, and they didn't think they'd sell any. Other trampolines at the time were much cheaper. So, that was a really smart business strategy. Go lower. But we had to start somewhere. And selling 1s, 2s, and 3s in a direct sale model wasn't how we thought we could get our manufacturing off the ground. As Keith shared, there was nowhere we could go to build this thing. We had to effectively engineer the production ourselves and teach the manufacturer how to make it. And the only people that were interested in doing that with us wanted to make a lot of them. So it was basically from 0 to 5,000 or 10,000 was what the model effectively we had to fill, and the only way to do that was to deal with a retailer, and we almost had to, we had to accept their terms at the beginning. It was successful, and we went back to them and said, we're not doing that again, but by then they'd sold out in, 7 weeks, and they were happy to negotiate, not first time around.
Thank you very much. Ladies and gentlemen, I can say definitively that we have the safest trampoline at MOTAT, just up here, and the exhibition is about to be open for us all to go up and have a look at. And Doug and Keith, I hope you will spend some time in the space and be able to answer any more questions and have more of this discussion, but with the trampoline, with Tagoma, and with some of the interviews that we have, both with your colleague John as well, playing. MOTAT, I think, have a little thank you to give you both. And ladies and gentlemen, can I invite you also to say your thanks to Doug and Keith? Thank you.
Yeah. Oh, yes, that's good.